Good morning, welcome to Advent of Code 2022, day 11. Monkey in the middle. As you finally start making your way upriver, you realize your pack is much lighter than you remember. Just then, one of the items from your pack goes flying overhead. Monkeys are playing keep away with your missing things. To get your stuff back, you need to be able to predict where the monkeys will throw your items. After some careful observation, you realize the monkeys operate based on how worried you are about each item. You take some notes, your puzzle input. On the item each monkey currently has, how worried you are about those items, and how the monkeys make these decisions based on your worry level. For example, monkey 0 starting items 79, 98, operation new is old times 19, tests divisible by 23, if true throw to monkey 2, if false throw to monkey 3. Okay, some weird computations here, and test is divisible. Each monkey has several attributes. Starting items lists your worry level. Starting items lists your worry level for each item the monkey is currently holding in the order they will be inspected. Operation shows how your worry level changes as the monkeys inspects as that monkey inspects an item. An operation like new equal old 5 means that your worry level after the monkey inspected the item is 5 times whatever your worry level was before inspection. Test shows how the monkey uses your worry level to decide where to throw an item next. If true shows what happens if with an item if the test was true, if false shows when the test was false. Okay. After each monkey inspects an item, but before it tests your worry level, you relieve that monkey's inspection didn't damage the item, causes your worry level to be divided by 3. Worry after each monkey inspects an item, but before it tests your worry level, your relief that the monkey's inspection didn't damage the item because your worry level causes your worry level to be divided by 3 and rounded down to the nearest integer. The monkeys take during turns inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding, one at a time, and in that order, in the order listed. Monkey 0 goes first, then monkey 1, and so on until each monkey has had one turn. The process of each monkey taking a single turn is called a round. When a monkey throws an item to another monkey, the item goes on the end of the recipient's monkeys list. A monkey that starts a round with no items could end up inspecting and throwing many items by the time its turn comes around. If a monkey is holding no item at the start of its turn ends. In the above example, the first round proceeds as follows. Monkey 0 inspects an item with a worry level of 79. Worry level is multiplied multiplied by 19 worry level. This is also the worry level. The operation is then the old. Do we need to keep track of the actual items? Not really, right? Okay. Monkey gets bored with item. Worry level is divided by 3 to 500. Currently, worry level is not divisible by 23. Item with worry level 500 is thrown to monkey 3. This should then be the case all the time, right? Okay. And throws it to monkey 3. Then let's check if we find it with monkey 3. Inspects. After round 1, the monkeys are holding items with these worry levels. Monkey 2 and 3 aren't holding any items at the end of the round. They both inspect items during the round. Aren't holding any items at the end of the round. They both inspected items during the round and threw them all before the round ended. So why is now the first round actually... The monkeys take turns inspecting and throwing items. On a single monkey's turn, it inspects and throws all of the items it is holding, one at a time. Each monkey has had one turn. So that means they get rid of actually everything in the round, right? It would have 4 starting items, and they both... And it just processes those 4 starting items. Yes. Okay. Chasing all of the monkeys at once is impossible. You're going to have to focus on the 2 most active monkeys if you want any hope of getting your stuff back. Count the total number of times each monkey inspects items over 20 rounds. In this example, the 2 most active monkeys inspected items 101 and 105 times. The level of monkey busyness is in this situation can be found by multiplying these together. Figure out which monkeys to chase by counting how many items they inspect over 20 rounds. What is the level of monkey business after 20 rounds of stuff slinging simian Chengians? So this in our check. Then, as I've understood, this is the input. And then we should also get our input. That's not that long. Good. Yeah, so so we'll create our monkey. And we either have let's just check. We have plus, 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 times, plus, times. Okay, that's fine. So for our monkey, do we want to keep track of the items in the monkey? Nah, let's for now. Let's for now just parse the start stuff. So we have val items, which is a list of int. Then we have a factor, and then we have just call it mul int and int, and we have that's actually also a thing we want to check. This is the only thing, right? Div test, also an int. And then we have true destination as an int, and we have false dest as an int. And then we can add the new. It's then anyhow divided by 3, right? So we multiply it and divide it by 3, and the test is then done with this. So we can just have a function that new item score, and the new item score is the new item score receives an item score, although these are all item scores then, so we can just call them item, new item, the old item, and that is just that's an int, and we say it's the item multiplied by mul. Then we add And then we divide by 3 to be divided by 3 and round it down to the nearest integer. So this is what we get anyhow here, rounded down always. So that's fine. For this, although we don't have the val here and we have the int here. And this is only the new item, and then we do a fun test item get destination. And this is actually item modulo diff test. If this is equal to 0, then we have the true destination, else we have the false destination, and this is an int, and we have the return here. Good. So, and we want to keep a monkey index here. Index int. Line dot val line is equal lines at position line index plus plus. Just create a new monkey start here. This is dot split. It can just say substring of monkey dot length, and then we take substring dot monkey dot length, so remove that, and then we will also say trim and then we will say, can't we do that? Or must it be, oh, I think it must be a character, right? And we trim away the colon, and then we want it to an int. Then we have the starting items. The starting items will do the same. Just remove that. Then we split it by, in this case we have the comma and the space, and then we map it to int. Then we have the operation. The operation will be, we have the line in there, yeah. Do we set the comma here? No. Then we want this operation to give us, what do we want? We actually can split it. This new old stuff stays the same, right? So what we basically do is this. Let's say we just remove just remove that part. And now we'll is it a map? Unsure if we can actually do that. Oh, I don't want the character, I want the whole string. Yeah. And then I would say if it at position 0 is yeah, we need this for two things here. So yeah, if it's at position 0 and we have the multiply at first, right, is equal equal to star, then we want this it to int, else we want it to be a 1. And then we need to have this closed, and we set a comma here. And we want to have that duplicated because the next one is our addition. But in this case, we're not allowed to do this here because we want to keep the same index. And also for the addition, we want to have a 0 if it does not match. So then we go further on. We want to parse our test. So the test is divisible by and we've actually removed this, and then we want to just have the rest of this to an int. And now we want to have the if true, if false, and this is just removing the monkey with a space, and we'll also remove that one by the same process. And then we should have passed our monkey, and then we get another line which we would just like to skip. Yeah. And this we can basically just create this monkey starts is equal to list of monkey start, and obviously mutable. And then we would say and then we add our current monkey to here. Parse monkeys, and we would like to have a list of start good. So I just say we'll debug this. Will receive a number format exception by the multiplication thingy. Yeah, this kind of makes sense. Yeah. So we would like to start substring 2 because we want to have away the space and obviously we'll need this here as well. This is now getting a bit weird. Might it just be... No, it's always this, right? It's always this kind of operation. Oh no! Yeah, we'll also have that here, yeah, that's true. Okay. That's actually a bit annoying. So I think we'll need to introduce. But this is the only thing, right? Yeah. So we'll basically introduce power here, which is an int. And we do the same, we do math.power, and the power would just be, yeah, pow. I can't do that with an... I think we can. We'll just need to. Kotlin power operator. Yeah, and fine. How do you do it then? Can we do that? Dot pow. Okay, can only do it for doubles. But this is entirely possible, right? Yeah, then. Okay. Whatever. And then we multiply this and we're done with that. And that's math.pow. Should be replaced with Kotlin. Yes, Kotlin. Yeah. Cool. Okay. Yeah. So that's fine as well. And we'll now copy that stuff here. And we do the test if we have the multiply operator, and we'll just say if it dot starts with, and we pass the multiply old here. No, if it starts with this times old, and in here we say starts, if it not starts with, otherwise we take a 1, and for the power we absolutely do the same, except in this case we don't parse it, but we'll just supply 2. Yeah. So then let's inspect our monkey list. For the example, we have 79, 54, 65, 75, 74. We have the power of 1, we have a multiplication by 1, and we have an add of 6. We had a power of 1 and multiply by 1 and add 0. Then we have the power of 2. We have a multiplication of 1 and we have an add of 0. The test is 13, test is 19, test is 23. True destination 3, false destination 0, 2 for the correct one, 1, 3, 0, 1. And the 74 with a power of 1 and a multiplier of 1 and the add by 3. So far so good. So, and then let's do our our rounds. We will want to keep track of the items, and the items we want to keep track in a mutable map of, and we have the, we can just use a lessor. Let me just think of, the kind of complicated thing is that only the monkeys throw the items they had, so we'll just take a list here and call that a list of ints here. And this list, does it need to be, I think it doesn't need to be mutable at the time. I think we're constructing it, so array list, is this something we have in Kotlin? That's all cool. I want to, it's a map, obviously. Yeah, and I think we should be fine with a list. So then we have a variable round which we initialize, I think, after round 1, so yeah, after 20 rounds, a bit unsure. While around smaller 20, we increase the round index here. And what we also do is we have items, and we will have a var current items. I think it even makes more don't think, do we need it for a starting point? Yeah, we want to set it up for the start, but we can easily do that within, I think. Yeah, let's just rethink that. But what we definitely want to do is we want to have next round next round items, and we need to want to record them during the round, and we want to operate on the current ones. So while we have our rounds here, we will loop through our monkeys, which is m in monkey start, and we will take our current items and get value for the current monkey, which is m.index, and then we will just process those items in current. This is current monkey items. Pass them the current monkey items, and for an item, we know that the monkey has it. We can obtain, so we would just say m dot new item would be item. That would be the new item. And the new item new dest is equal to m dot get destination for the new item. And then we would say next. We should declare this here, var can initialize it here, we can initialize it at the end. And this is get or put. Do we get or put for the new destination? And for the new destination, we will get and or put, and in this case, we would put the mutable list of in there. Do we need it? Well, maybe. Kotlin, need a function. Yeah, we don't need it. And then we have the var. And to whatever we have here, we want to add get or put. Yeah, so we should have a list here, right? Next round items. This new items. Let's just check what this is. Yeah, and then we can just say add. No, we can't, because this is specified as a list. Yeah. Immutability strikes again. And we add the new item here. Good. And then we initialize the next item with a new this is mutable list, and we want to say that the current items are the next around items. And we got the new destination by testing below, and the current items will be mutable list as well. And we have the round counter. And then we should actually be done after round 20. The only thing what we still need to do is we'll need to initialize our current items. We'll see if we can do that. Just take monkey starts dot associate. We'll need to return a pair, so this would be it dot index and it dot to it dot items dot to mutable list, and this can be then, I think we can just have it like this, right? And we want the monkey inspected items 101 times, and we can keep a count, just inspection count. We can just we take our monkey starts dot associate it dot index to 0 counts, and then in here we have the inspections, and we can say inspection count at we want to update the value actually. Not really sure if that works, but we can have m.index is equal to inspection counts dot get value at that position plus plus, and this then obviously associate to mutable map. Plus 1. Yeah, okay. That's true, yeah. So I think these are the counts, and then we would need to go to our inspections dot values dot sorted, take last 2, and we'll need to multiply them, or expected 100 times. The left rank business is this can be found by multiplying these together, and then we would b times a times b. How does the call signature look for this? Okay. More top monkeys is equal to that. Then we would say top monkeys and we'll reduce it to this, and this is this, how is it called, business, and then business to string. Good. Then let's see if it works. So the current items, key 0 is missing in map. Yeah, okay. We learned that this can now actually happen. So we should do it like this. Now let's do it like that. It's, I think, cooler. We'll do this here for every monkey, no matter what. We will just, not for the inspection, I don't care. We want, I think this one we can make easier. I would just say for the next round's items, we always initialize it for the m.index, and we just set it to a mutable list. And then in here, we can just say get value at this position, and then we can also just then we can just do it like that. And the new destination, that makes sense because we don't know if we hit it was actually, it actually doesn't work like that. But we actually found a different problem. No, we have the new destination here, we are fine. We did it correct, yeah, okay. So, but we can have it that we don't actually have anything here. So, in this case, this is just empty list. This would just be an empty list, yeah. We get a business of 12. That doesn't seem very good. Let's check our top monkeys. 3 and 4. But we kind of did 20 rounds. 2, 4, 3, and 1. Yeah. So let's yeah, this one obviously ruins it. This also doesn't give me a lot of confidence. So let's see where we are stuck here. We have the round. We actually set it. We have the next rounds. We'll put items to that. For each monkey. The current one is overwritten here. In the next round, 3 monkeys have items. So let's check how this works out. The monkey 0 should have 20, 23, 27, 26. And the monkey 1 should have this one and this one. But it shouldn't have the... Those are fine. But monkey 3 shouldn't have any items. For some reason. And the next round items, they are initialized with empty. So monkey 3 should actually not have any items. And that's let's just check. Monkey 3 would only get items from the monkey 0 or monkey 2. So let's just go along with that one here. So we would actually like to check after the first monkey. So we have our next round items, and only from monkey 0 is thrown to monkey 3. Item is worth worry level is thrown to monkey 3. Item is thrown to monkey 3. Yeah, that's actually correct. But monkey 3 does already operate on those or not? Well, monkey 3 starts out with only one item. Ah, okay. So they do already process them. Ah. Okay. Now then I misread that. So if they do already process them, we don't really need the next round items, right? Yeah, not really. The only thing is we need to make sure that, so I think the easiest is we remove it here. So then we want to have the current items. Get the value for this one here. And we add them there. We don't need to update that. But what we need to do is if we will anyhow process all our items. And we know that we have processed them, and there is maybe there is a loop in there where we self-assign them. So if we actually get them out of here, we can just for safety reasons already say on our index, and we now we need to get a value for that one, so that we can now safely say this is empty list. mutable map, and we'll just set it to an empty list of int. Mutable empty list. Mutable list of sum. So we clear it before, and yeah, then should be fine. And we're now in monkey business. Unchecked solution is this one. Submitted. So you're worried you might not ever get your items back. So worried, in fact, that you're relieved that a monkey's inspection didn't damage an item no longer. An item no longer causes your worry level to be divided by 3. Unfortunately, that relief was all that was keeping your worry level from reaching ridiculous levels. You'll need to find another way to keep your worry levels manageable. At this rate, you might be putting up with these monkeys for a very long time, possibly 10,000 rounds. With these new rules, you can still figure out the monkey business after 10,000 rounds, using the same example above. Inspect item. So we don't really care here, they can't be that high at that position. Destination shouldn't also not get that high, but we'll not be that sure here, so that's why we put in a long here. And we'll test this. And the true destination, they will stay, that's fine. And here we have the same. We'll put this to a long, and we multiply. This should be fine. And we'll just copy over this to here. But this item is defined in current monkey. Items to mutable list. So the inspection count, well, bit unsure. Top monkeys is now along. So where do we have int? Yeah, for the parting this is absolutely fine. For the destination this is as well. And this is definitely 10,000. And we'll adapt this to this. And what we'll also need to make sure we have our inputs. Yes, this number seems right above the integer thing, so that's why I'm... And if we have this 10,000 here, we do it to string. We take the last, and I need to get rid of the divided by 3 somewhere. This one here, which now will not make our first example work, but we'll fix that later. Then type mismatch the item. Item is coming from current working items. This is coming from current items. Yeah, I'll need to adapt it to here as well. Items.map, it's too long. Although we don't run this part currently, but yeah. Mm-hmm. I mean, this should anyhow work, but just to be sure. Hmm. Mm-hmm. Mm-hmm. So I'm a bit confused. Therefore I'll puzzle answer was this one. Okay, I at least ruined it for one as well. Yeah, okay, but for one, it's kind of obvious that I did because I removed the divide by 3 here. So if we run it again, how did that happen? Yeah, okay, 20. Mm-hmm. What else did I change? I shouldn't have changed anything else of the code, right? Don't think I should, no? So if I do that, put that away, I should actually have the same numbers for the second. Well, no, if I keep that divided by 3 here, and then just check with the part 2 here. Yeah, at least I end up with the same numbers. So then if we remove the divided by 3 here, we do multiplication, we do the addition. I mean, we can all make them too long, but I think everything anyhow is too long, so and in the input passing there shouldn't be any change. Did we update our inspection counter? We did. I mean, we can still make it an L here, but it is. And then we want to have 10,000 rounds. Yeah, let's just give it a check how we look after those rounds. So, our inspection counts are 99, 97, 803. Okay. So let's just can I say evaluate expression? Can I put that into here? And the count is anyhow not, so let's just put this to 1,000 and say evaluate. And then we should have our current items. No, not the current items, but the inspection counts. So yeah, we're definitely off here. So maybe with this incredible power thing here, but these are only the inspection counts. Maybe we really end up in having an issue with integers here. Maybe we really do. Or with integers, but for the test we'll need to get it down again, so this will not really help us, right? Can we? We can give this a try. Why not? Mhm. 0L. Mm-hmm. Mm. Ah, we have a big int here. That's what I wanted to have. Big integer. Mm-hmm. Too big. Big. Well, there is a too big decimal. Yeah, okay, those are doubles now, so mm-hmm. Blah 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 blah. We have the power here, then we have too long. Yeah, if I put this too long, then I'm not gonna. Let's just revert this double stuff here. So, bit unsure about this power function mal1 is equal to, if power is equal to 1, then mal1 is just, then we just take the mal, else we take item. Then we can get rid of this weirdo thing here, just call it item, and we multiply it with mal1, because it's only in one of those anyhow. So, still unsure what's happening, but I would say we give it a run and check if we still have the same results. No, we don't, but we don't have the division by 3 anymore. But if we add that again, We're back to our original solution. Yeah, okay. Still confused how this can... Okay. So... Let's put here another 10,000. Yeah, I mean, I'm pretty sure this is not working, but yeah. At least we now know that this one is too high. Too high. Just noted it down here. Yeah, I mean, we are definitely off, but the question is how we can figure out like we have been off by at 1,000, but we still were correct at 20. Yeah, then I would say let's really bring in the big int. I think it's worth a try. The big... I'm confused. So we have the big decimal and we have a big int. The big integer is from big decimal as well. But I can convert them to big decimal. I can also do that for big integer. But I can only do it for longs. Okay, that's somehow only possible for longs. And then I don't need to do this. Okay. This is now interesting. For some reason this now works. Clearly, because this item, this would meet... yeah, okay. Equals 0 big integer. Yeah, or around, but 10,000 is still not an issue for an integer. This returns the correct root, but the item that's in here, current monkey items, associated it dot. To big integer. And then we have the same here. I mean, pretty sure this is not needed, but just put 1000 there. This takes ages. But we not really understanding that. Also, can we really run out of the long that easily? And can we, like, even if we run out of the long, which might at some point make sense, but why does this computation now take that long? Not really understanding that fully. Interesting example though. And we are already off with after 1000 rounds. We need to spend some time somewhere. Collecting data. This is really weird. But we're at around 960. I think this is due to some behavior of the big decimal, the big integer. And that's, I mean, weird. But we were around 960, so I would have let it continue until we maybe at some point reach 900 and reach the 1000. Just to have some kind of comparison what's going on here. But to be honest, I have no clue. Is there something like a very small condition where we may be doing things wrong? Let's just check the is divisible by. Because we're still getting the correct results for 20 rounds. So this is something that's really weird. Actually, so the monkey starts are, but they are a list, so we go through the monkeys in the correct order. This can't really be the issue. I mean, we're keeping a lot of big integers here, and I think this causes the performance problem we're currently experiencing. But let's just think it through. Let's say we even exceed the double. But then we still have the dividable tests, which are a bit annoying to deal with if we don't have the longs. I mean, we might even exceed 64 bits, which would be cool actually. Would be really cool puzzle thing here. But I still have a hard time believing it. That's not really adding up for me now. Also a bit what's going on with the, but we can't do the following. We can maybe just run it. Maybe it's faster without the debugger. Yeah. Yeah, we could try the doubles, but for the division tests, this is actually bit of an annoying thing to deal with. I mean, we can divide. So the mol one. Here we remove the big int here. This to a double. And we can do the test. So we'll receive the item and the item divided by the diff test to double will give us a certain result, q, and if we take q and yeah, should we just round it to an int? Let's do q times q too long times this, and if we are off by less than, yeah, this is percent, this is even, minus q dot long this is really hard to figure out. If 0 so we'll take the item, multiply it with the divisor, and if this difference between those two is actually smaller than 0.001, then we say it passes our test. Is true. Then we do a to double here. Put this to 20 and we search for big. And do this to double here as well. Okay. So put this to 20 rounds here. Set the debugger here. Give it a try. So the inspection counts are wronger than before. Let's give this a try. If this already fixed it. This really means we're doing 1 or 2 wrong decisions. That's actually not that. Can we say item dot? Not really sure what rem is, to be honest. Of truncating division of. Maybe that is what we want to have, and the remainder. Kotlin check double with epsilon. Is there compared to long bits? Double dot equals delta. Oh, okay. Yeah, okay, anyhow. If they just Mm-hmm. Yeah. Well, actually, this is the remainder. I want to check if it's almost 0, so it should be below 0 dot. It should actually just be below 1, then I would be fine. So this is now would now be again correct for now. So then I'll take this and say evaluate expression. Unfortunately, we don't have anything between 1000 and this, because I fear we will be wrong here again. Yes, and we are wrong again. Mm-hmm. Okay. Most probably not gonna figure that out now. Well, maybe you can solve it during the day. Thanks for joining in. Have a nice day.